Hi, my name's Callum, and I'm building a rocket engine. So, context. My name's Callum, I'm from Suffolk. I'm currently studying engineering at the University of Manchester in my third year. And why am I building a rocket? Seems stupid, right? It is stupid. But rockets are cool. Rockets are really cool. I want to work on them when I'm older. I want to build them now. After my second year, I applied for an internship with all the launch companies I could find in the UK, and none of them got back to me. So, clearly I'm not good enough for them, but I'm good enough for building it in my garage. So that's what I'm doing. I'm doing it myself. This is where we're going to build a rocket engine, in my favourite place in the whole world, my garage. And I hope you enjoy.
Okay, so how is this all going to work? So we're building a liquid bipropellant rocket engine. So we need to machine a combustion chamber able to withstand the high pressures that this entails, and at the same time also build a fuel tank able to withstand the same high pressures. To pressurise the fuel system, we need a tank of high pressure inert gas, and for the oxidizer system a tank of high pressure oxygen. And finally we've got to figure out a way to plumb it all together and remotely operate it using valves. Okay, so that's how everything's going to go together, and this is how it should work. So the high pressure gas sources will be regulated to the required pressures, and then they pressurise the system up to the valves. From a distance we'll open the valves, and they will pressurise the fuel tank with the inert gas and force the liquid fuel from the fuel tank to the combustion chamber, while at the same time the high pressure oxygen will be fed directly to the combustion chamber. A remote ignition system should ignite the fuel and start the burn. The rocket will run until the fuel runs out and hopefully doesn't explode. So, how hard can it be? Okay, starting with the combustion chamber, I wrote a code that takes the important parameters of the rocket engine and spits out a diagram and all the dimensions how it should be built. I'll be honest, I don't really know what I'm doing, but it seemed like a good start. Putting all the dimensions together in CAD, we get a 3D model of the rocket engine, plus a few other bits of the injector assembly added on. Finally, this 3D model generates a blueprint for us, and all there is left to do is build it.
Hey kid, don't ever let them get inside your head. They'll tell you what to do in life instead of everything you know that you could get. Don't let them guide your life towards regret. I'll fight for what I love with every breath. My past is filled with things I won't forget. I use them all to push me to my best. So treat the worst of times just like a test. If only I could go back in time, I'd tell myself that everything will end up alright. Just push yourself, test yourself, figure out what you like, and find your limits, don't be rigid, always work towards a prime. Surround yourself with open minds, people can change your life. A few friends with intent can help you feel alive. Find a passion, take some action, and with a little time, just be patient, make a statement, try to enjoy your life. They'll try to kick you while you're down. They wanna rise up while you drown. They wanna fill your head with doubt. They're silently scared.
Okay, so with the combustion chamber done, we have to think about how we're going to get the fuel into the rocket. Because this is a liquid rocket motor with bipropellant, we need a way of pushing liquid and gaseous fuel into the combustion chamber. So we're doing this with a injector that you can see is attached onto the combustion chamber with two plates. This should be strong enough to hold the 300 psi, which is loads of pressure in the combustion chamber, and should give us a big, loud rocket engine.
They don't wanna see me make it, they don't wanna see me care. Anytime I make some regardless, I can see that they compare. I think everyone's against me, maybe something in the air. Am I paranoid? I swear a void is forming.
Okay, the fuel tank. As I said, it has to withstand the same pressures as the combustion chamber. To make it do this, we'll make two circular ends with threaded holes for high pressure hydraulic fittings to screw into. The ends will be welded into a 3mm thick steel tube, turning it into a high pressure fuel tank. The whole thing will be surrounded by a steel cage in case of any rupture in the tank or in case my welds fail. It is the first time I've done this. So I've made two of these, which are little ends. You're going to go in like this. I'm going to weld around the outside, and this whole tube becomes a fuel tank. Okay, the final part of the puzzle, the valves. One of these will control the flow of nitrogen and fuel, and the other one will control the flow of oxygen. They have four main parts, plus a few 3D printed gears and connectors. A high pressure valve is in charge of controlling the flow, driven by a geared high torque DC motor. A rotary encoder is used to determine the angle the valve is turned, and a bracket, one from carbon fibre, the other valve from stainless steel, holds it all together. Okay, so at this point, we've got the combustion chamber, it's done. We've got the injector finished, fuel tank done. I've got the hydraulic lines, I've got the regulators, I've got the tanks of gas, I've got the fuel. I've got everything. We're ready to go. Next step, we put it together, and see what happens.
Welcome to the first test launch of my rocket engine. We're here at my nan's farm. It's probably the coldest day since winter started. Everything is icy, it's very foggy, but hopefully we're going to heat it up with some rocket engines. Pressurise this up and see if my wells.
What is that, sorry?
This is the fuel tank. This is the fuel tank. As you'll know from earlier in the video, hopefully. Hopefully the valves do what I tell them to do, and then we can test the fuel tank pressurisation.
And then things started going wrong.
Nothing from the outlet, buddy.
First, the outlet valve stopped opening, meaning we couldn't control the gas flow.
Outlet not.
Then, even after that was sorted, the rotary encoder for the Zane valve stopped outputting the valve angle, and that meant we had no way to know the valve was open or closed or halfway open. And then by this time, it was getting really dark and we couldn't see what we were doing, and there really wasn't any other choice other than to go home and try again another day.
Come on. Give me a break.
So here we are, a week after the first test, where first of all the valve stopped operating, and then second of all the rotary encoders stopped communicating with my laptop, and that second one was what really messed us up. And apparently all it was this piece of cardboard that I put between the steel, like that, and all the connections on the bottom of the rotary encoder. Apparently I did the bolt up too tight and the connections came through, and it was bloody short-circuiting on the steel. And that was it. That was the only reason we couldn't fire the rocket last week. How flipping annoying is that? Anyway, solved it now, and try again tomorrow. Okay, here we go, test day number 2. Luckily most of the setup was already put together, so we only needed to do a few bits of plumbing and wiring before we could pressure test the fuel tank.
Check. Check. Fire.
Good to go. Health and safety. I think I'm supposed to scream fire in the hole. I think you might alert the neighbours.
To weaken them. I'm only being argumentative. Working, otherwise you've broken the game. I'm sure you have.
This is my safety coat. It's nice and thick, so if anything explodes when I'm in there, I won't die.
You have a nervous wee.
Hello.
To pressure test the fuel tank, we were pushing 300 psi worth of nitrogen into the fuel tank. We'll be opening an inlet valve, pressurising the fuel tank, closing it, and then opening an outlet to release the pressure. Valve's open. No explosion. Closing the valve. Valve's closing.
Wow, nice. Days.
Right, opening escape valve.
Success! Yeah?
Once the fuel tank has passed the pressure test without exploding, we're ready to set up and do a cold fire on the rocket engine. Okay, cold fire test, BEL rocket engine, Mark 1.
Well, that was exhilarating.
I think you might.
I think this one opened and didn't close. I think this one didn't even open. Wow. Oh my word, that was the best thing we've had so far.
One is opening, two is opening, they're both opening. They're both open, don't they?
Okay, well, I'll be honest, I'm pretty happy with that.
Okay, so those cold fires were really successful. It showed that nothing leaked, nothing blew up, everything went together okay, it's strong enough, and it just proves that all the work that I've been doing over the last 6 months is good and it's worked. It's been the first time that I've done so many of these processes in such magnitude and with like such responsibility. The forces on this thing are quite incredible, and yes, it was really successful and worked so much better than I thought it was going to. Unfortunately, there wasn't a hot fire, and I'm sorry about that, but I promise in the next video there'll be a hot fire test. And before we do that, we're going to have to upgrade these valves and the motors on these valves because they're just terrible. They're awful. They're so unreliable. But I mean, look what we're asking them to do. 300 psi is going through these things, and the motors are tiny, so I should have anticipated that. But and anyway, Spaghetti Station is ugly. It's terrible,
I hate it. Skin replaced. I don't like it. But we're going to do those in the next video. We're going to go back and we're going to hot fire test this and see if it can withstand proper rocket engine-ness. And yeah, other than that, all I have to say is thank you so much for watching. It's my first YouTube video. I really hope you've enjoyed it. If you have, maybe like, subscribe, share, leave a comment if you have any thoughts. Like I say, it's my first time, so feedback's definitely welcome. And yeah, I'll see you all next time. Thank you very much.